Good morning and good afternoon, everyone. Hopefully everybody can hear me clearly. I'd like to welcome everyone to this edition of Carbon Talks from Carbon Next. I'm Hayden Francis, Manager of Carbon Tech with Carbon Management Canada, and I'm excited to be co-hosting today with Shannon Wilson from Foresight Canada, ably assisted by Samantha and Astrid. And with gratitude and respect, I would like to acknowledge the lands on which we operate are the traditional, ancestral, and unceded territories of the First Nations, Inuit, and Métis people. And we'd like to invite you all to place your own land acknowledgement in the chat, if you like. Carbon Next is a partnership between Carbon Management Canada, Canada's carbon capture, utilisation and storage subject matter expert, and Foresight Canada, Canada's clean tech accelerator. We're grateful for the support of Prairies Can and Scotiabank in bringing you this program today. Together, we accelerate CCUS technologies through innovation, ecosystem development, engagement with industry, government, and policy, collaboration with industry partners, and promotion of events like this one today. And we have an exciting and thought-provoking discussion prepared for you today, as we dig into the importance of measuring, monitoring, and verification, or MMV, in carbon capture, utilization, and storage, CCUS, and its relationship to carbon markets and digital platforms. Marie McKay of Carbon Management Canada will present our keynote presentation outlining the CCUS landscape and framing the challenges and importance of MMV and CCUS. We'll then shine the light on three ventures in the CCUS space, supported by Carbon Next, Brandon from Mangrove Systems, Trent from 3P Technology, now Highfold, and Sam from Carbon Graph. And each will discuss the challenges and rewards of being a venture in the CCUS space and how they're trying to tackle the challenges we are facing. Today's discussion from our ventures is not a pitch session, but an opportunity really to connect them with the community, and for you to ask them questions and raise any thoughts that you may have. And as we progress, we'll invite you to drop questions for our presenters in the chat box for our moderated Q&A session, which will follow. Now, I'd like to invite Marie to open today's Carbon Talks. Marie, if you'd be so kind.
Well, thank you so much for the welcoming remark. I am Marie McKay. I'm the Manager of Subsurface Research and Project Delivery at Carbon Management Canada. And I'm focusing on a monitoring program for CCS, especially a geophysical program in my own case. If we can switch to the next slide. Yes, I'm going to talk about the importance of MMV, measurement, monitoring, and verification in the CCUS space. What we are at, what we need, what it is required, and what are the challenges for MMV. Next slide, please. So I'm pretty happy because a few years ago, I was starting my talk with, we need to scale up what we are doing by 100-fold, and it was a very pessimistic thought. And now I'm really happy to start my presentation with, we are seeing more and more projects and bigger projects, which is pretty exciting. So as you know, CCS, CCUS, geological carbon storage, there is different acronym for the different, basically main thing, but putting or trying to remove carbon from our atmosphere and either storing it, utilizing it, start to be widely used. And on this figure, you can see on the right, the map of the 25 prospection projects that were approved in Alberta. So those projects might not see the live, I'm sorry, but they have the authorization to prospect and to do some injectivity tests. And hopefully they're going to turn into real CCS projects, so uptake of CCS projects here in Alberta, but also all around the world. And on the left, on the bottom left, you have the size of the plume that you might expect when we start talking about big projects, large projects. 10 million tons, it's few kilometer diameter, but when you start to talk about very large projects, you start to reach plume diameter that are very, very large. And it's a challenge for monitoring, basically. You don't want to spend a lot of money on monitoring. So the big question is, how do you monitor those huge amount of projects on one side and those large projects on the other side? Another question is also when you have a lot of projects injecting in the same interval or the same target, injection target, you can have some interference around those projects. And MMV is going to be a very, very critical tool to be able to monitor those possible interference between projects. Next slide, please. So MMV, why do we need MMV? Measurement, monitoring, and verification plan. It's not in order of importance, but it's some of the reasons why we need that. So one of the reasons is because we need to build public confidence. We need to have public with us, because public are having an influence on politics and are having an influence on money incentive to develop those projects. So we really need to have a very good relation with the public and explain them what we are doing, and that what we are doing is safe. We obviously want to verify the containment and the conformance of the reservoir. Those projects are a little bit costly, so you want to make sure that what you put in the ground stay in the ground. You want to make sure that there is no leakage that can leak into your groundwater and your soil system. And also you want to have a good MMV program to make sure that the carbon credits you might request for those projects are validating. So what you say you are putting in the ground is actually in the ground. And you want also to comply with the regulatory, different regulatory framework that there is around the world. A few requirements for those MMV plan. So this is the one put together by the province of Alberta here in Canada, but each province, each country have their own principle and objective, but they are all revolving around the same requirement, more or less. So obviously you want to comply with the regulatory framework. The MMV plan is going to be project and site specific. You can't have the same MMV plan for all the projects. It has to be adapted to different case scenario if you are onshore, offshore, depending of the reservoir type. So each site is going to have its own MMV. But you also want to address the regional impacts, and especially when it comes to possible plume interference. Again, it's going to be risk-based and fit for purpose. So again, each site is going to have its own MMV. It will have to be adaptive, especially because we are talking about a long project, 25 years injection sometime, and sometime a very long monitoring period after the end of the injection. Technology is evolving a lot those past years, and you want to make sure that those MMV plan can integrate those new technology in their plan. It has to provide timely warning of containment and conformance anomaly. So really, as soon as there is something wrong in your reservoir, you want to be able to detect it. You want to monitor everything going from the geosphere, hydrosphere, biosphere, and atmosphere. It has to be transparent, and it's circled back to the public confidence that we want to build. And lastly, it has to be best available technology, but also economically achievable. There is always a cost related to those monitoring technology, and we want to make sure that we have the good balance between accurate measurements and cost-efficient monitoring technology. Next slide, please. And it's what we try to do at Carbon Management Canada, part of what we try to do. So we have a test site that we are using to really develop those monitoring technology for CCS and CCS safety. So the main goal of CMC is to reduce the cost and improve monitoring technology for CO2 storage. So kind of a playground for research institute, for oil and gas company, for startup to come and test their tools and compare their results against each other. Next slide, please. Just a very beautiful picture of a site. I love it, so I put it here, but yeah, just to illustrate the site we are working on. Next slide, please. So what we are doing at the Nouvelle Conti facility is simulating a leakage. So we put a small amount of CO2 on the ground, and we are working on detect that small amount as soon as possible. And it's come back to be able to provide information on possible anomaly as soon as possible. As soon as you have an anomaly, we want to be able to detect it. So we work a lot on detection threshold for all those different monitoring technology. And it's a kind of a space where we are working together with the operators, with the regulatory body, with startup to try to shape the future of CCS and especially shape the future of MMV for CCS. Next slide, please. This is an example of a monitoring plan that you can build. Again, each site is going to have its own MMV, but it's kind of the tools that you can use to build your own MMV plan. It's a function of coverage. So are you able to monitor just small points or the whole plume? A function of the resolution you want to have. Do you want to have a blurry idea of your plume, or do you want to have an exact idea of the CO2 saturation in your plume? Cost is obviously a huge constraint when it comes to MMV. And when do you want to do those different technology tools? So again, if you take Quest MMV run by Shell, you're going to have a different MMV plan. If you take ACTL, the Alberta Carbon Trunk Line, the same. So really, what you have is a toolbox of monitoring technology, with each one of them having their own specificity, and you want to pick in that toolbox and build your MMV and make sure that it is fit for your own site. Next slide, please. And yeah, I just want to close the presentation with some additional thought or random thought or whatever you want to put that. So why we are doing MMV? Again, we want to ensure the safety of the groundwater, of the soil. You want to make sure that what you put in the ground stay in the ground and be able to measure that and be able to claim whatever carbon tax or incentive system is fit for your province or country. But also building public confidence is going to be a crucial key. We are pretty lucky here in Alberta and North America in general, because we are very aware of oil and gas and that kind of stuff, although there is a bit of pushback against carbon tax, but that's another story. But I'm French, as you might have noticed, and you might know that French people love to fight and go on demonstration and strike, especially against things that they don't understand. So we want to make sure that the public education is well done and they trust what we are doing, because any failure that's going to happen anywhere in the world is going to have huge implication for all the projects around the world. We often forget when we talk about monitoring, but monitoring includes also a baseline, and you need to have an extremely robust baseline. There is some of the monitoring tool that you can go back in time. So for example, when you are using INSAR, it's based on satellite, and you can find old satellite image. So this one you can go back in time, but for some technology, you can't do that, especially seismic, especially geochemistry. So building a robust baseline is extremely crucial. And that is very early in the stage of your project, before you are doing any injection, even before you are drilling any wells, because You want to think about the MMV you want to build and possibly use the wells that you're going to drill to build that MMV. So the planning the MMV has to be one of the first stage for most of your project. I said that numerous times, but we don't have a MMV plan that's going to work for everybody. It's going to be site dependent and project dependent. The tools remain kind of the same, but you have to pick your specific tools that is going to work for your specific project. And pilot and research sites are a critical component for CCUS development and to test, assess monitoring technology. We need those sites to act as a playground for people to come and test their monitoring technology. There is a lot of things happening right now, and you're going to see some example of new seismic source and those type of stuff. We need a site to be able to test those, and pilot and research sites are extremely valuable for that. And I think that's my last slide, if I'm not wrong.
Well, thank you very much there, Marie. It's really great to hear those contextualizing last thoughts about the importance of MMV and how it will be site specific, and that not one size is going to fit all, which shouldn't perhaps be that surprising, but nonetheless, when we start to think about these, it's really important. And we can now see how MMV is highly important to the development of public and market confidence in CCUS, and how the scientific rigor plays an active role in the development of carbon, or will play a role in the development of carbon markets, and certainly the work that Carbon Management Canada is doing at the New County facility, proving out these things in a practical way. I believe from previous discussions with you that facility is designed with the intention that we might actually fail, or show what it might be like if a facility were to fail. So quite different, perhaps, than an industrial commercial scale injection plant such as Quest's project, or Shell's Quest project. I'd now like to introduce Brandon from Mangrove Systems for a discussion in relation to his carbon management infrastructure. Brandon, if you'd like to.
Great, thank you very much. If we could just get into the next slide. So hi, everybody, I'm Brandon. Appreciate you all joining, and thanks to Hayden, Shannon, and the team for putting this carbon talk together. I'm going to start off by introducing a bit about myself and how I got here, and then I'd love to take a couple moments to share a bit more about what we're building at Mangrove Systems. I'm pretty optimistic that there's a lot of folks on this call that may be interested in what we're doing, so I appreciate you taking the time to learn more. Next slide, please. So this is just want to share a bit more about myself. I always thought this was funny. My mom actually found this recently when she was moving. She found this paper that I wrote in grade 5 or 6. Basically said I wanted to get into some type of clean energy, and I cared about the planet. That's the key takeaway here. The blurred section talks about caring about computer science and building a business, but I always find this interesting that now that I've started some companies and now I'm finally in a space that I really care about, looking back and how prescient this type of thing was. Next slide, please. And a bit more about my professional background. So I actually founded a bank for small, medium-sized companies in Canada called Loop. And over the last 8 years, we've financed a significant amount of renewable energy projects across Canada. And after doing that for 8 years, that felt really good. And I felt like I was helping kind of move the entrepreneurs starting those projects and generally Canada in the direction that was the future. After I left Loop, I started an emissions modeling company called Carbon Interface, and we delivered emissions modeling and LCAs via APIs to companies so they could create carbon footprint estimates quite quickly. But what happened was one of my first customers was in the business of carbon storage, and they needed some modeling done for them to do some baseline work. And that's where I was kind of introduced to the whole concept of geologic storage for CO2, CCS, CCUS, and the more frontier type of technologies like carbon removal. After speaking with a lot of folks in that market, I kept hearing the same thing over and over again, that these projects are going to outlay a ton of CapEx to develop, but there's this constantly evolving market. And that's kind of what Marie just commented that when you're developing the MMV plan, a key part of that is making sure that it aligns with the regional goals or requirements, especially when it comes to accessing value streams. And that's actually what Mangrove Systems is laser focused on. Next slide, please. So what we're building is the leading carbon management platform for CCS and CDR. We actually started last year. Our first client was actually based in Norway, but it looks like we're going to secure some clients in Canada and the US shortly. And right now we're actually tracking more than 5 million tons of CO2 through our system. That's a combination of projections from certain facilities and storage sites, as well as actually CO2 that's been either removed or captured and stored permanently underground. Next slide, please. And basically what we're building for this market is a carbon system of record. I think the best analogy that I have is in finance and in accounting, you typically work with your accountant and they will tell you what tools to use to make sure that you can organize your finances of your business in an appropriate way. Typically that tool looks like an ERP, like an SAP, a QuickBooks or something similar. But as these projects scale up and come to market in the CCS world, a similar process and system needs to exist for them so they can engage these markets, whether it's a market like TIER, the BCLCFS, the Federal Clean Fuel Standard, or the array of programs available in the US like 45Q and 45Z. The other thing is, Marie also talked about the importance of MMV on managing community relationships and stakeholders. And what we're focused on is making sure that this data is easily portable for either communities, regulators, auditors, verifiers, or any other parties that are involved in this process. Next slide, please. And this is kind of an example of what we're building. So we're actually working with companies that are building multi-party systems. So they have multiple capture entities. They have a transport mechanism and then a storage site. We're basically working with these companies to collect all this data. For some of these projects, there's over 200 data points per entity. And we basically load that into a ledger. Once all this data is stored and collected, we're able to say that this ton of CO2 that's gone downhole use this many kilowatt hours from this grid, this many kilowatt hours from this grid, has this losses associated, this venting event, this fuel use, et cetera, so that with that information, they can accurately and in a trustworthy way engage all these programs that are coming online, whether they're voluntary, compliance, or tax related. Next slide, please. And this is a great example of a challenge that is coming on a market in the US right now, which is in a multi-party system, when you're storing a molecule of CO2, you have to correctly attribute the share of emissions from transport and storage back to the particular capture entity. That's important because a lot of these programs, whether it's tax credit programs or compliance markets, require the filer to actually be the capture entity. So the capture entity actually needs a robust accounting and a robust ledger of all of the inputs that actually took place in order to store that molecule of CO2. So there is a heavy computing side to this and a heavy data collection slide, but our goal is obviously to make this easier for these companies and projects. Next slide, please. And this is kind of obviously one thing that we need if we want this market to grow is we want entrepreneurs and folks that are excited to generate value in a market. And one thing we're helping companies do is as we collect this data in their system, we're actually able to help them optimize or set out what programs they should engage in at different times. There could be CO2 that's stored that has an emissions profile that's very beneficial for an LCFS market, or an emissions profile that's beneficial for a VCM. So our ability to gather all this data and store it in a structured way will hopefully make it possible for companies to drive revenue so they can decrease their cost of capital, raise more money, build more projects, and ideally help decarbonize these heavy industries that are hard to abate. And that's it. So I really appreciate everybody for listening to this presentation. And I wanted to share a bit more about myself and my background, as well as what we're building at Mangrove Systems. I can post my email in the chat if you'd like to reach out. But again, I really appreciate Hayden, Shannon, and others for putting this on today. Thank you very much.
Hey, Brandon, you're very welcome, and we're very grateful for you to take the time to spend with us here today. I'm hoping I've successfully unmuted myself with this new technology I'm working with. Now I'd like to invite Trent from 3P Technologies up next, and I believe he has some interesting developments to share, including the introduction of his new operating name. So Trent, if you would please.
Yes, thank you, Hayden. Highfold Technologies is been in the technology development space in Alberta for the past 10 years. Our background is using electronics to generate impulses for various industrial applications. And we were exposed to the CCUS MMV space about 5 years ago, and were challenged to develop a tool specific for that application. And in that intervening time, we've built a prototype, we've done 3 field tests, and we're now embarking on a semi-permanent installation at the CAMI site. So what I was challenged with in our technology development, as Marie put in her matrix, was the cost of acquiring seismic data, which is in our industry kind of the gold standard in monitoring techniques. There are many others coming, as Marie indicated, and especially on the geologic side, we deployed our tool for that specific purpose to lower the cost of acquiring that data. And we've been able to prove that it meets the requirements for compliance and equivalency to other seismic methods like vibrosize or dynamite, etc. And one of the comments that I was asked to talk about in our development technology timeline was some of the resources we've relied on to get to the stage we're at and some of the challenges. We have been very successful engaging with the provincial and federal funders, specifically IRAP, and has been a big supporter of our developments. And one of the, I guess, key challenges that I can relay to other entrepreneurs that want to enter the space are basically 2 things. One is being cognizant of the timelines that you're going to have to meet. And it's not very quick. It's usually a fairly lengthy process. And the second comment that I'd make is that most of the granting bodies are looking for various quantifications, I guess is the right word, of pull-through or market impact. And that can also be challenging. And I think some of the tools that have been discussed today will help with that pull-through capability. So that's really all I've got. We have a unique proprietary seismic source, and we're deploying it. Back to you, Hayden.
Thank you very much there, Trent. It's interesting to hear the challenges you faced as an entrepreneur in this space, and certainly when it comes to looking for funding and non-dilutive funding sources and the timeframes that are involved. I know from some other work that I'm involved in that the timeframes can be quite long, and when you're seeking funding from the time you make an application to the time you get a decision, it could be 12 months. And sometimes the questions that are asked in those funding applications maybe are not absolutely fit for this kind of industry or these activities, because they're thinking more about the production of an individual widget or a service that somebody might do, or something that's very quantifiable in terms of economic development or creation of jobs. And certainly in the work that we do, things are not always that well defined, and that can provide some challenges when you are seeking funding or looking to advance or develop the technology. I can see that we've got a number of questions coming in, and I've certainly got a few of my own, so we're going to save those up for later, but please do keep posting them in the chat. Now Sam from Carbon Graph will discuss their experience in the CCUS venture space. Sam, if you would please.
Hi, everyone. It's a pleasure to be here. My name's Sam, and Carbon Graph is lifecycle assessment software. So for anyone who's not familiar, lifecycle assessment is a study to understand the overall environmental impact of something, usually a physical good that a company is producing. And the life cycle means going from raw materials all the way to consumer and eventually end of life. And the assessment part includes many different environmental metrics, of which carbon is a primary one and is the area that we focus on. So companies use Carbon Graph to understand the carbon footprint of their products. They can take that data and they can add it up to understand their scope 1, scope 2, and scope 3 carbon footprint as a company in more granular detail. But often they also use it as a means of understanding the supply chain and understanding how individual elements of their supply chain reduce their carbon footprint. So where this connects into the CCUS space is really two areas. And I think I'll briefly share my screen, if that's okay, and show you what this looks like. Or maybe I won't be able to because we have the Zoom can't share screen issue. So let me know if you're able to let me share my screen, but if not, that's totally fine as well. But so what we do, we connect into the CCUS space in two areas. So one is CCUS technology itself. We are able to assess the overall carbon footprint of a process. And I think, Mangrove gave a great example of that. For a known CCUS system, you can track all of the energy inputs and all of the carbon storage systems. We also are doing some work primarily in newer areas of carbon credit generation. So for example, agricultural storage of carbon in soil, and attempting to help companies quantify overall, how much carbon is going in, how much is going out, and what can you claim credit for. So this, for example, on screen is an example of what Carbon Graph looks like when it's assessing a supply chain. So looking at a tomato as it goes from a farm through distribution networks to a supermarket. And the second way that we fit into the CCUS space is if anywhere in the supply chain, somebody is capturing carbon or is in some way reducing their carbon footprint below what would be considered the industry norm, or the emissions factor for people who are familiar with carbon accounting, then Carbon Graph is a great way to measure that. So we're really interested in actually helping to shine a spotlight on supply chains where CCUS is being used and show how that is reducing the overall carbon footprint. There's a term that some people may have heard recently that's coming into the carbon vogue, which is insetting. So insetting is different from offsetting. And the idea is that if you offset, you are paying for carbon reductions potentially on the other side of the world. If you're insetting, you are paying for carbon reductions within your supply chain. And for a variety of reasons, that is, generally speaking, being seen with a higher degree of validity for a lot of applications than purchasing carbon offsets. And so where companies are actually interested in deploying CCUS technology, we're able to help quantify those benefits and deliver some sort of commercial results to help pay for the investment in that technology and then the marginal cost of storing the carbon. So for anyone who's interested in learning more than happy to connect offline and tell you more about Carbon Graph. Thank you.
Thank you very much there, Sam. That was a really interesting, discussion. And we can see that being an entrepreneur in this space is certainly an exciting, challenging, and rewarding experience. I think we built up a bank of questions here, and I'd like to kick off one that was originally posted in the chat, but I'll bring it forward into our discussion here. So Philip asked a question from Marie to start. Philip asked, where are you storing CO2 in geological strata? What do you see as the role of groundwater in pressurizing, sealing, and stability of the storage?
Sorry.
And 1 minute there, Marie. I think I think our field trip last week out to the CAMI site has out to our new accounting facility perhaps has given you the hay fever.
Sorry about that. Yeah, I probably partially answer to Philip in the chat, but yeah, so when you are injecting CO2, usually you want to inject at more than or deeper than 850 meters to be in supercritical phase, which is a very nice phase of the CO2. And actually in Alberta, you have to store it at deeper than 1 kilometer. So you check those reservoirs, and the groundwater is usually way shallower than that, but we still heavily monitor it in order to make sure that we are not contaminating that groundwater due to CO2 leakage from your reservoir. So yeah, and yeah, I have to. So yeah, trying to follow the chat at the same time as talking is a little bit tricky, but yeah.
I think there was a second part to the question, which is this is also typical of the aquifer's influence on natural gas resources.
Yeah, exactly. So yeah,
monitor.
I have to think a little bit more about that.
I wonder, Marie, if you could, if perhaps for our audience, if you could just let us know whether or not at the Newell County facility, is the storage going on into rock, or is it going on into a saline aquifer?
Yeah, so usually there is a different type of reservoir, but the main one around the world are saline aquifer, so that water is not drinkable because of the saltiness of the water. And the other one is depleted oil and gas reservoir, either by trying to do oil recovery. So you pressurize the reservoir and try to suck up the remaining oil from that reservoir, or just the empty field that you already remove all the oil and gas, and you can put CO2 in place of that. So that there is no link to the groundwater, properly drinkable, potable groundwater. But I have to think about sealing. I don't think it can act as a seal, but I'll have to think about that and come back to you, Philip. I'm sorry.
That's great. I have to keep checking here. I have a new device, and I find myself making sure I'm constantly not on mute. This I look like I'm talking and nothing is happening. So let's have a look and see. Shannon, did we have some other questions from the audience there?
Not at this point. I think we can go with our other questions.
Oh, that's great. So perhaps a question for the group, and I'll let either one of Sam, Trent, or Brandon take this one. What resources did you utilize during your entrepreneurial journey that you would recommend to others?
I can take a stab at this to start, and then maybe Sam, I saw you can hop in. I think the key thing for us was we had a really big learning curve to get up to speed on. I don't particularly have a background in like energy, which a lot of people do getting into this space, I would say. So what we used is a lot of customer conversations, and I was absolutely surprised at how open and how transparent potential customers were of being very clear about what their needs and wants were in a solution. And what we did is, after we heard the same challenges articulated over and over again, whether if it's in Europe, Canada, or in the United States, it was very clear that there is a problem to be solved. That obviously goes beyond like the typical like grant funding, groups like Foresight or Carbon Next and things like that. But I think for us, what really helped us ramp up was doing workshops and exercises with prospects.
So an early client or potential client engagement perhaps has been instrumental in in helping you move things along.
Yeah, in our case, it was absolutely critical. We wouldn't exist without it.
Trent or Sam, what do you have some thoughts on this one?
Well, everyone is on the right track here, because I think Foresight was probably the single best first decision that I made. You know, when Carbon Graph joined Foresight at the time, Carbon Graph was myself and a laptop. So I think getting that external guidance, you know, you might start a company and now you're the CEO, doesn't make you the CEO of Goldman Sachs, right? You actually have to talk to people who have some experience managing a business, have some experience in the space, have some experience with the unique elements of clean tech fundraising and clean tech entrepreneurship. So just getting that network, that external accountability is incredibly important. I think recognizing that you have to tell a lot of people about what you're doing for a long time before you might start seeing some traction and some support. And I think Brandon made a great point. You can kind of hit two birds with one stone. So like the first 6 months of Carbon Graph for me was really just taking meetings with anybody who'd be willing to give me their input on the space in general, and you know, being a sponge. At a certain point, you need to learn when to stop being a sponge and stop letting input cause you to change priorities every few days or every few weeks. And you have to sort of switch back and forth. But being a sponge, forming those relationships, it was, you know, 5% of those connections that we made, or 1% of those connections that we made, that unexpectedly came back 6 or 12 or 18 months later and became an investor or linked us to a customer that created those kind of step change results. So you can never really know, you know, when you're going to be successful in getting that first customer, when you're going to be successful in getting that first investor, that first IRAP project, getting into an accelerator. But you have to, you know, have those at bats, and then eventually you'll start to see the results come back, and then it's the journey just sweeps you up and takes you on your way.
Excellent.
I have very little to add to what Brandon and Sam indicated. Client engagement, I think, is paramount, and that's ultimately how we've got to where we are at. And then along the way, with that customer pull and that engagement in that marketplace, I've been able to engage funding bodies through IRAP. I failed to mention earlier, Alberta Innovates is also a supporter. So we've been able to garner that kind of non-dilutive financing for our technology development. But it all starts with client engagement.
Excellent. I wonder too, this is a question that I'm going to pose to Brandon, but it perhaps also connects to, you know, to MMV and how it will work. How will regulation drive an engagement with what you're doing, and perhaps how will that, you know, how will measurement MMV? I always trip on that particular acronym. How will MMV, you know, connect with that?
Yeah, I think regulation will drive a lot of what decisions get made in a compliance monitoring and reporting plan, for example, that is used at a site. I think there's a couple drivers. Like, one is regulation, the other is obviously like safety, and you have operational concerns and things like that. But I think what's interesting on the regulatory side is, for us, we work backwards with our clients. So we look at what the regulations require for the tax credits or for different compliance programs and voluntary programs. And then we come up with a data sheet of all the data points we need to be collecting on the MMV side. But 99% of them would already be collected because of the site plan that was originally developed before the construction of the site occurred, as kind of Marie said. But what we do is we go back and we say, okay, all these attributes are being collected, great. And that's obviously what we will bring into our system. Regulation is good, I believe, for the industry and our business.
Excellent. And Sam, if I'm remembering things rightly here, you know, a lot of the work that you're doing is perhaps about developing labeling for products or for systems or for services. And helping people understand, you know, perhaps what is involved in that that bag of Rice Krispies, how will the measuring, monitoring, verification play into what you do, and how will that connect things together for you?
Well, I think, MMV that's taking place in carbon capture, utilization, and storage right now is a basic model that ideally will expand to every kilogram of greenhouse gases that are emitted or captured around the world. So whether that's explicitly storing, compressed CO2, or if it's just the combustion of fossil fuels, or biological or agricultural processes. I like to say that carbon accounting is not rocket science. Most carbon comes from burning some coal, burning some oil, burning some natural gas. And it shouldn't be too difficult to be able to track down where those are taking place. But the problem is we have these complicated global supply chains. And when you buy or sell something, the price that you're paying. So we have a whole financial accounting system that starts by measuring individual financial transactions and builds up to the point of, securities markets and insurance and all of that. We need that same basic MMV of carbon transactions in the carbon economy to underpin. And I think in some ways we've kind of built the top layer. We've built the corporate carbon reporting, we've built the ESG dashboards for investors and things like that, without actually really having the basic accounting of what's going on at the product level. So what's happening in CCUS, I think, is a great counterexample to that. And it needs to be, of course, but I'm hoping to basically take that and expand it to other areas.
So if I'm hearing you right, what you're saying is you're really looking to bring forward into people's everyday lives the impact of their daily choices and consumption.
Absolutely, bring it forward to people, but also bring it forward to businesses, because not everyone should need to become an expert in what a kg CO2e is. For people to be able to feel comfortable, if they shop at a certain grocery store, if they buy from a certain brand, that brand is acting responsibly. And we have things like the Science-Based Targets Initiative, for example, which I would point to as probably one of the leading things that a company can attach themselves to in terms of responsibly managing their carbon footprint. But we need to give companies, and especially small and medium-sized businesses who live in supply chains and often control a lot of emissions directly, the tools to be able to talk about their carbon footprint, talk about how they've reduced it, monetize that reduction to be able to pay for more reductions and things like that.
Change it up a little bit here and have another question I think we have another question coming here from Marie. We often talk about measurement, monitoring, and verification, but we also talk about measurement, reporting, and verification. Are these two acronyms the same thing? Are they interchangeable, or are they something different?
I think they are kind of the same thing, except that for the monitoring, reporting, and verification, you include that business part where I think the end goal is to claim any carbon tax or carbon credit, or the other side, carbon credit. So they are the same, but just I think philosophically they might be a little bit different, just like there is a business for MRV, and maybe MMV would be more for regulation and public confidence and that kind of stuff. I would love to be proven wrong or right by the audience.
And I also wondered, does anybody else have any thoughts on on those two terms? I mean, there's a lot of acronyms out there in the work that we do, and certainly in Canada we love acronyms. We love anything that has 3 or 4 letters that rolls up to a word. So what does the rest of the group think about the differences or similarities between MMV and MRV?
I think the key thing is that M&M or M&R are basically like your internal controls and your systems you're developing. The V typically should be done by an outside party. So that's that could be a group agency or entity verifying the data. And again, the analogy I come back to is in financial accounting, you have your own finance team, your own accounting team, your own bookkeepers, they put your books together, and then you bring in a firm. And if you're kind of engaging certain markets, you have to follow IFRS, and that's where you'll get an accountant, and they'll come in and they'll basically follow rules and procedures to audit you and make sure you're compliant. They'll use tools like population analysis and things like that to make sure you're compliant. But I think the thing that we're seeing on the either credit origination, whether it's tax, compliance, or voluntary credit side, the V is typically done by an outside auditor, verifier, or group. So M&R and M&M, I don't know, like that may be semantics, but the V part I think is critical.
So perhaps an opportunity for a business to develop then for those people who are going to be who might be involved in the audit work, the verification and audit work that's going to be involved in advancing carbon markets, and possibly in the development of standards as well, that we may come to comply with.
Yeah, absolutely.
Excellent. We're getting towards the end of the time here. I guess we had one other question had come in from Marie. In fact, could be for Trent or for Marie. What's the biggest challenges to deploying tools, measurement MMV tools, or perhaps tools that are going to help investigate and verify the sequestration of carbon dioxide? What is the biggest challenge to that?
Marie, I'll let you take that one.
There's so many challenges. I don't want to end on that pessimistic note. I don't know. I think there is different challenges that we're going to face in the next few years, and it's first convincing operator that we need MMV. There is unfortunately some operators that are still claiming that MMV is an optional part of your project, which I don't think is true for all the reasons that we talk about. It's also very difficult because as there is no one plan that can fit all the projects, it's a little bit of a huge task. Cost is always a challenge, but I mean, which is a little bit unfair because monitoring is one of the cheapest part of your CCS chain, basically. So, but still, if you can cut corner as much as you can, I think that's the goal. But cost will remain always a challenge, especially when you start talking about those use projects. You don't want to do 3D seismic on those use projects, so you have to find some other monitoring technology that is able to monitor that plume without paying a lot. Something that we start to think about because we start to see a lot more projects is the plume interference. When you start to inject in the same reservoir, even if those projects are kilometers apart, especially the pressure of plume can interfere and build some pressure increase at the edge of those two plumes. So there is almost a philosophical question of who's going to take the blame if something wrong happened between those two projects, because even though as a scientist we know that there is no culprit, we'll have to find one for other stuff. So that I think that question of finding a cost-effective way to monitor those huge plume, but also I don't know, be able to find a way to monitor and understand those plume interference is going to be a big challenge for the monitoring future, basically. So I can find a lot of other challenges if you want.
And I'll just mirror what Marie had indicated about cost. And that's one of the challenges that we have directly targeted is lower cost. And at the same point, lower cost, but also low CO2 deployment. The equivalent technologies are very CO2 expensive because they burn fuel, as Sam indicated earlier. And what we've undertaken is to develop a tool that has virtually zero CO2 development because we explode water. And that's the uniqueness of what we do.
Just checking here to see if we have any other questions coming in. Is there any other questions from the audience there, Shannon?
We just have one, but I think Philip answered it in the chat. So I think
Okay. No worries. One last question before we go. How at the moment, how is CMC, or how does CMC keep track of the CO2 that they are putting into the ground? How do they know it's in fact the CO2 that they are putting in, and perhaps not the CO2 that might already exist in the soil, or or in the ground?
So it goes to the geochemical and geochemistry realm, which is not my strong suit. Yeah, CO2 exists in the subsurface. It is produced by a lot of different processes, and you have to be able to discriminate the source of the CO2 if it's coming from those natural sources, like, I don't know, bacteria or that kind of stuff, or the CO2 you are putting yourself in the ground that might have leaked to those subsurface groundwater or soil. So that you need to characterize the CO2 you are putting in the ground, and if you detect any CO2, you have to be able to make sure that is the CO2 that you are actually putting in the ground. So it's some geochemistry analyze based on isotope to understand the source of the CO2. And again, so that geochemistry, so that's a little bit far from what I'm doing. Yeah, CO2 exists in the ground, and you have to make sure that the CO2 you are possibly monitoring and recording is due to those natural processes or the CO2 that you put on the ground. Making sense.
Thank you, Marie. It sounds like an opportunity for an even deeper dive in future with some of the folks who are involved with the geochemistry to do with carbon sequestration. Shannon, do we have one more question? And then perhaps time for us to wrap up the show today.
Yeah, we have one of our audience members with their hands up. We have about 1 minute for you, Sapiens, if you would like to come off mute and ask your question.
Yes, I had it left in the chat. So my question is very simple. Is for Sam. What are your main challenges right now? What is the most difficult thing you have to do that you'd like to solve and going forward in the next year?
Raising money. We're currently preparing for a seed round, so that's going to be a challenge. Always is. And also figuring out, where to go. I think we've got a lot of opportunities with our technology for what features to prioritize and who our ideal customer is. And so one of the learnings this year has been, you can't be everything to everyone. We've had to get increasingly more and more specific about who our target customer is. And even though that feels like it's closing doors, it also yields, much more excited results and better engagement from those people who we do now focus our energy on. So we're trying to close our first enterprise customer right now, moving from small and medium-sized businesses to enterprise, and selling software to big companies is a whole field unto itself that I'm personally new to. So that's been the learning, is how to sell to big companies and then how to raise some money on the back of that and to support more selling to big companies.
Thank you, Sam, for the
awesome. Thank you, Sam.
Well, that's about all we have time for today, I think. I would like to express our gratitude to all our speakers for giving their time to be with us today, and also to our audience for your attendance. It's shaping up to be a busy summer with plenty of events and conferences to attend. In particular, we'd like to draw your attention to the Carbon Capture Canada Conference in Edmonton, where you'll be able to catch up with some of the team from Carbon Management Canada. And I'll also be attending the World Petroleum Congress here in Calgary, both coming in September within a week or so of one another. And we'll be back here in September with the next edition of Carbon Talks, highlighting more of our Carbon Next supported ventures and talking about point source capture. So with slightly 1 minute past the hour, I thank you very much for your attendance and look forward to catching you next time. Have a great day, everybody.